Hi everybody, my name's Sean Handley, and today we're going to be talking about creating instances on OpenStack using Shade. Shade is part of the OpenStack Infra project. It's a Python library, and let's see here, the introduction says that this is a simple client library for interacting, and the key word here is simple. So OpenStack does a hell of a lot of things out of the box, but this library hopefully keeps things nice and straightforward. So what we're going to be doing is, before we can get cracking with this, we need to sign up or sign in to the Datacented public cloud, which is a UK-based OpenStack public cloud platform. Full disclosure, I am an employee there. So we'll take the login route for the time being. I'm going to assume either that you've signed up or that you've been given some credentials for accessing this. So what we'll do here is we'll log in using the email address that we've signed up with and the password. And what we'll get here is we'll be logged into the Datacentre dashboard. So within this UI, we can view all of the projects that we have set up on OpenStack. So you see here we have a project called Test Project 1. Within this project we can see that myself and David Flanders from OpenStack are both assigned to the project. This means that we have the ability to connect to our OpenStack public cloud platform via the API using the same username and password that we use to log into this dashboard. So if we, I'll just sign out and back in here. If we land here on this login page, which is the OpenStack dashboard horizon, you can find that here at compute.datacentre.io. If we log in here with the same credentials as before, then we see here that we're successfully logged in. So that's pretty awesome. What we're going to do then is we're going to dive into using Shade. Now, Shade assumes that you're going to have a cloud setup in a YAML file, which you can have in the same directory as your Python code. So if we just do a little ls, we can see here we have clouds.yaml and shadetest.py. So here in the YAML, you have a top level key called clouds. It's the same in all clouds YAML files. And then here we have the name of the cloud that we're going to connect to. In this case, it's Datacented. So under this, if you put your username and the password that you use to log into the Datacentre dashboard, the only other two bits of information that you need are auth URL, which is the same for everybody all of the time. So that's compute.datacentre.io, port 5000, v2.0/, and that should be enough for it to connect. And then the other thing that you need is the name of the project. So the first project that we have here is Test Project 1. You can see that here in Horizon as well. That all matches up. And here we have a nice blank instances UI with nothing in it. So we'll hop over to the Python code. Now, the first thing we need to do is import the Shade library, and then the second thing that we do is we create this cloud object that we can call API methods on. So the way you set that up is with shade.openstackcloud, and then you say cloud equals, and then the name of the cloud from the YAML file. So that matches up here with this key. And if that's all been done correctly, when you run this code from within Python, jump back to my terminal, then we have this cloud object that we can call commands on. So there's a few things that we need to do before we can get an instance up and running. First of all, we need to decide on a base image to launch that instance from. So if we have a look at how that would be done in Horizon, if we hit the launch instance button up here, we'll give that a second to load. And at this point, yeah, you need to select a boot source. So if we boot from image, and then somewhere down here we have Ubuntu 16.04, and then all we need to do is give it a name and select a flavor. So within Python, thing that you have to do is very similar. What we're going to do is, this is a UUID on OpenStack, on our OpenStack platform at Datacented. This image is a Ubuntu image. It's the same image as the one that I've selected here. You can get that information using a separate API call, but I'll leave that as an exercise for you guys to read the documentation and try that out. But for this example, we're just going to pick this one, and that's Ubuntu. The next thing that we're going to do is pick a flavor. So line 6 here, we have get flavor by RAM, and we're going to pick a flavor that has at least a gig of RAM, and this method here will return that. And then we just need a name, so we're going to call this test server. So if we take this code, put it here into the interactive Python shell, then we have each of these set into a variable. So if I do print image, you can see this munch output. So this is an object basically serialized as a dictionary here in the terminal. You can do the same thing with flavor as well. So now we have all of this information. We should be able to create server as it is, and that would work just fine. However, we're going to do a couple of extra steps here, because we want to use SSH to connect to this server, because then we can do useful things with it. So first of all, what we're going to do is we're going to create a security group rule. It's going to go into the default security group, and it's going to be for port 22. So the way you specify that is with a min range and a max range, and you set them both as 22. We say protocol TCP, and direction is ingress, which means traffic coming into the server. And if we take this code, put it in Python, and run it, we get an error, because apparently I've already created that rule. So rule ID is this. So that's all well and good. That's just me doing some testing before doing this screencast. So that's nice. That means that if we jump into access and security, and then within this we will have a list of security group rules. So let's take a look at that. And there we go. Here at the bottom we have this ingress rule 22. What I'm going to do is I'm going to delete that rule, and then we'll run that same command again, and this time you see it comes back without creating an error. And if we refresh, we should see that rule has been created there at the bottom, and it has. Good. Okay, so the next thing that we're going to do, by default, the Ubuntu image is going to allow SSH access, but only using an SSH key, not with an SSH password. So what you need to do is, here where I've said public key equals, this is where your public key goes. This here is my public key. If you need any assistance in creating your own public key, your own SSH key pair rather, there's great instructions here on GitHub for producing that. So the URL is help.github.com/articles/generating a new SSH key and adding it to the SSH agent. So you can follow those instructions through. It will give you a public key and a private key. Don't use the private key for setting your key pair, just give it your public key. And once that's created on the server, you can reference it by name. So we'll take that public key and we'll put it through this cloud.createKeyPair method here. So we're going to create a key pair called myKey, and we're going to give it that public key that I've put into a Python string. So if I paste that in, boom, unable to create key pair. This is because the key pair already exists. So same thing again. This is just me doing some testing before we really got started here. If I jump back into Horizon, we should be able to see that public key pair. There we go, my key. And I'm going to do the same thing that I did with the security group rules. I'm going to remove that, and we're just going to run that command again just to prove that it will work. So let's jump back to Python and cloud.createKeyPair, and we've got a success response there. And if I refresh this page here, we should see that key pair displayed here in the list. And we do, so that's awesome. So quite a bit of setup there just to get to this point, but now we're actually ready to create the server. So what we've done is we've picked an image, which is Ubuntu. We've picked a flavor that has at least a gig of RAM, because We want a server that's powerful enough to run Ubuntu smoothly. We've given it the name test server 1. We've made sure that our project has a security group rule that allows inbound traffic for port 22. We've created a key pair which is going to allow us to access this machine via SSH, and finally we're going to wrap all of that up into the culmination of this, and we're going to create that server. Now, there are two options that we've passed here that I want to talk about while we wait for this to boot. That's wait equals true and auto IP equals true. So wait is going to wait for the hypervisor on the cloud platform to finish provisioning and launching that machine, and it has. We've got this response back here. So that means that the machine has started and Ubuntu should now be booting. Auto IP equals true means that what we're going to do is we're going to assign a floating IP address from the pool of floating IP addresses. So floating IPs are public IPs that you can assign to any of your machines, and it means that you can access that machine from that address. So if we jump back to Horizon, we should be able to see here in this list of instances that we now have an instance called test server 1. It's running Ubuntu, and it's been assigned this floating IP 184.543.218.187. So what we should be able to do now in the console is jump out of Python, and we should be able to say SSH Ubuntu, which is the default user on Ubuntu. What SSH will have done is add our public key to the list of authorized keys, but you still log in as the user Ubuntu. You don't actually have an account. So Ubuntu at 185.43218.187. So we get asked, do we want to accept this host? Is that the valid key? Yeah, that's a good fingerprint for us. And here we go. We're in. We're in a Ubuntu server. We can see the root file system. We're definitely on Linux. We're not on a Mac anymore. We should be able to sudo, and we can. So now I'm the root user, and there we go. We have a fully functional Ubuntu server up and running and ready to do whatever we need to do with it. And that's all in 14 lines of Python, more or less, thereabouts. So I've rattled through those steps fairly quickly. Before I go, I'm going to refer you through to this page here, which is docs.openstack.org/infra/shade/usage.html. So this is the API reference for the Shade library, and all of the things that you might want to do are defined in here, all the method names that you would call, all of the arguments that you would supply, and what you should get back from that. So this is definitely a point of reference, and from this point you can carry on learning and seeing what you can do with the OpenStack cloud. So that's it. That's all from me. Thank you very much.